He's not responding. Anthony Johnson. Okay. It looks like it's right. That's good. I think you screen shared. Okay, we're good now. We can keep going. All right, so does that look familiar to you guys? Did you guys do the acute obtuse thing or not? Yeah. Some of it, that's one of those things that's kind of like sometimes they do, sometimes they don't. For our class, the thing you really have to understand is you have to know the top one. You have to know how to use that in order to find the missing side of a right triangle if you're given one. Okay? So that would be the key one here. This is the big one you have to know, and I know that's something you all can do. All right? Now, what I want to do is I want to go straight into special right triangles. Okay? Because special right triangles, we're going to use Pythagorean theorem for us to generate the rules for special right triangles. Okay? So here we go. So special right triangles. There's two types. There are 45, 45, 90s. And there are 30, 60, 90s. These are the two different special right triangles that exist. This one's also referred to as an isosceles right triangle because if you recall in geometry, if you have two angles of a triangle congruent, the sides opposite have to be congruent as well. Okay? So boom, boom, boom. Okay? 45, 45, 90. Again, what I was just saying was if those angles are equal, so are these sides. That's why it's called an isosceles right triangle as well. Now, if I know that these legs are equal, I can mark them the same. So instead of saying A and B, I could just mark them both letter A or both letter B or any letter I really want. It doesn't matter. I'm just going to call them both A. All right? What is this over here? This is still the hypotenuse, right? It's C. So let's write down the Pythagorean theorem for this. What's the Pythagorean theorem going to say for this? Well, it's going to say that A squared plus A squared equals C squared. What's this give me? 2A squared equals C squared. Now, I want this to just be C. So I have to take the what? Square root of it. So I take the square root of both sides. Now, what do I get? I get C is equal to, here I get radical 2 times, what's the square root of A squared? A. Which means C is equal to A times radical 2. Boom. There it is. That's the rule. This rule basically says this. If you are given the leg, either one, it doesn't matter, and you want to find the hypotenuse, you multiply by radical 2. That's all you would have to do. That's it. A times radical 2 will give you this. Sometimes it won't be an A, it will be the variable X. It does not matter. It's a variable. Okay? So this is the shortcut rule for 45, 45, 90s. Okay? So I'm going to go ahead and here's what you would probably see if you were given a sheet like this. This is probably what your sheet would look like. It would say this is X, and this is X times radical 2. That is the rules for 45, 45, 90s. There it is. That is the rule right there. For special right triangle, if it's a 45, 45, 90. Which means I don't have to give you two sides. I could just give you one side, and you could find the remaining two sides. Like, let's say I gave you this. Here it is, boom, boom, boom. Let's say I told you that this was 5, and I wanted you to find the remaining sides. That's easy enough. What's this going to be? 5. What's this going to be? 5 radical 2. You be done. Done. That's it. That's all you would do on that type of a triangle right there. Okay? Let's do another one. What if I gave you this? Here we go. 45, 45. This time I give you that this, let's say this is 8. 8 divided by radical 2. And remember what I told you in the past? Do you have to rationalize that and change it? And the answer is no, not for me. You can leave it like this, and that is completely fine. Okay? So there it is. Boom, got it. Are we okay? Now, does anybody remember that now? That you did see that? Okay. If you haven't seen that, you're going to want to remember this. Okay? You're going to want to remember this. Okay, so that's the 45, 45, 90. Any questions on it? And again, we used what? Pythagorean theorem to do it. That's all we used. Now we're going to go ahead and do a 30, 60, 90. Let me get a clean page here. All right, so 30, 60, 90. Okay, so before I do this, I'm going to draw an equilateral triangle, which is a what? All sides are equal. Okay? So I think actually that might be one of the shapes. Yeah, we'll do this. That looks pretty good. Okay, so let's say that this is an equilateral triangle. Okay? If it's equilateral, it's also what? It's equiangular as well, right? That means all of the angles are 60 degrees. So this would be 60, this would be 60, this would be 60. We okay? So everybody understands that, hopefully. Right? Here comes a question for you. This is a new question. Here we go. Okay, what kind of a triangle would you say that is? It's isosceles. Okay? This is nice. Okay? So this is isosceles. Great. I want to know if, what do we call this angle up here where the two legs equal sides meet? It was called something. It's called a certain angle. I remember my geometry. It's called the vertex angle. These are referred to as the base angles. Okay? The vertex angle. If I were to draw from the vertex angle an altitude coming down like this, what can you tell me about that altitude, what it does? You remember anything it does? And this came from geometry. It does. What does it do to the vertex angle? It bisects it. It bisects it. So these two pieces are the same. What does it do to this base side? It also bisects it, where these now are equal. And yes, that's why you have two congruent triangles in here now. All right, so here we go. An equilateral triangle is a type of isosceles triangle. It has at least two sides congruent. So I'm going to draw an altitude down right here from this angle. Boom. Now, what do I know? Right away, what happens to this angle here? This becomes 30, and this becomes 30. Okay? All right, are we ready? Let's go ahead and do this. I know, let's see here, pen. I have purple still? I do, great. I'm going to say that each of these sides here, original sides of the triangle, I'm just going to call each one of these X. X, X, and X. Those were the original three sides of the equilateral triangle. Who can tell me what this is going to equal right here? 1/2 X or X over 2. You can write it either way you want. This is X over 2. All right, so here we go. So what I'm interested in right now is this thing. This green triangle right here is a 30, 60, 90 right triangle. This is the 30, 60, 90. Here's 60, here's 30, this is x, and we just said that this is x over 2. I want to find this missing leg of the right triangle. Let's just call it B, because I don't know what it is yet. All right, here we go. I'm going to use Pythagorean theorem. It would be x over 2 squared plus b squared equals x squared. What do I get here? X squared over 4 plus b squared equals x squared. Okay, here we go. B squared equals x squared minus x squared over 4. Now, what am I going to have to do to this right-hand side? Not yet. I don't want to do that yet. I want to combine those. They're like terms. What do I have to rename this x squared? I'm going to add these. These are what? This is like fractions. What do I have to make this? 4x squared over 4. You're going to rename this as this. Isn't that still 1x squared? But I had to have a common denominator, right? So what do I get now? I get b squared equals 3x squared over 4. All right, great. Let's keep going. Now I'm going to do what Brady wanted to do. Now I'll take the square root. B equals, okay, it's going to be the square root of 3 times the square root of x squared over the square root of 4. What does that give me? Well, what's the square root of x squared? X. Radical 3 over 2. There it is.
What did you do with the x squared? How come you're allowed to add the 4 to the top and bottom?
Because in order to combine these, I had to have a common denominator. Since this is 1x squared, I can make it anything over itself. And I just had to have a common. The denominator here was 4, so I made this 4. If that had been a 6, I'd make this 6x squared over 6. So look what we have now. The hypotenuse is x. This is x over 2, and this is x radical 3 over 2. Now I'm going to put this on a new page. All right, we're going to take this and look at it on a new page because I'm going to change it just a little bit. Oh, I got to get that changed. I can't use my fist to erase anymore. That's going to drive me nuts. Okay, so we said this is x over 2. We said this is x, and we said this was x radical 3 over 2. Now, here's what I'm going to do. To make this a little better, I'm going to take all of these sides and multiply them in the exact same factor. If I do that, will I still get a similar triangle to this? Yeah, because they would be, the corresponding sides would be proportional still. I'm going to multiply all of these sides by the number 2. I'm going to multiply this side by 2, I'm going to multiply this side by 2, and I'm going to multiply this by 2. And guess what I get? I get this rule now. X, 2x, and what's this one going to be? X times radical 3. Boom. That's the one you want to know. That's the one you want to know. So look what we know. Oh, and guess what? We call the side opposite the 30 the SL. What do you think that stands for? The short leg. We call the side opposite the 60 the LL, and that stands for the long leg. And of course, we know this is still the hypotenuse over here. It doesn't matter. So what do I know? if you have the short leg, this is the one you like. If you have the short leg and you want the hypotenuse, you multiply by 2. If you have the hypotenuse, want the short leg, you do what? Divide by 2. If you have the short leg and you want the long leg, you do what? Multiply by radical 3. If you have the long leg and want the short leg, guess what you do? You divide by radical 3. Always. Always, always, always. This is the rule for special right triangle 30, 60, 90. Okay? X, 2x, x radical 3. Okay? Again, 30, 60, 90s. 60, 30, boom, x, 2x, x times radical 3. So x is the side of the short leg. Okay. That's the second special right triangle you have to know. So we have to have them for 45, 45, 90s, and we need them for 30, 60, 90s as well. Okay? Because these are going to come back to us after spring break. Knowing those are going to come back to generate something else we're going to want to be able to work with. Anybody have any questions on anything that just happened here? And I'll post all of this online. You can check it out later if you need to. We're okay with that? Yeah. This part here? Because back here, because this, it all came back to this equilateral triangle. When you draw this altitude, it cuts this into half. Since the original side was x, this has to be x over 2. That's where that came from, that x over 2. So I had to have those two sides in order to find this one here using Pythagorean theorem. Okay. Anybody else have a question on this? Okay. So let's just do a couple practice problems on 30, 60, 90. Just a couple. All right, here we go. So let's say I gave you a 30, 60, 90 here. And let's say I told you that this was 5 and I wanted you to find the missing sides. I have given you the short leg. So how would I get the hypotenuse? I would take the short leg and do what? Multiply it by 2. So it would just be 10. How would I get the long leg? I'd have to take the short leg and multiply it by boom, and I would be done. And if you plug these in the Pythagorean theorem, it will work. Guaranteed. Guaranteed. Because I can try now. This squared is 25. This squared is 75. And 75 and 25 is 100, and that's what 10 squared is. Guaranteed to work. Okay? All right? Let's say on this one I gave you this. Okay, so this time I gave you the what? Hypotenuse. Which side that's missing should I find first? The short leg, exactly. So what would the short leg be? 4. What would the long leg be? Boom. That's pretty easy. Okay? Here we go. One more. I've given you the long leg. Where am I heading first? Short leg. What am I going to divide the long leg by? Divide by radical 3. So this is going to be 5 radical 6 divided by radical 3. What is radical 6 divided by radical 3? Radical 2. So what do I get here? 5 radical 2. Now I want the hypotenuse. So I take this and I multiply by 2. When I double this, do I multiply both of these by 2? No, just the outside number. Okay? Are we okay with that for the most part? And maybe with practice later on we can get better at it, but if we have a basic understanding right now, that's what we need. Okay. Let's keep going. Right triangle trig. That's the other thing we have to talk about today. Right triangle trig. Trigonometric ratios. All right. So I know you guys remember this. Every geometry teacher I've ever known uses the term or the saying SOHCAHTOA. Every single one of them does this. I know they do in this school at least. Does anybody know what S, O, and H stand for? Great. Okay, so here we go. Let's get a triangle up here. Okay? So here's my right triangle. So I need an angle on this. Now, one thing you're going to notice in here is, like in the past, you a lot of times would see your triangles and they'd be listed as ABC. Okay? Let's say this is the angle I'm interested in down here. This is the one I want. What is this angle named? What's the name of that angle? I could call it BCA. I could call it ACB. Yeah. Why can I also just call this one angle C? When can you use a one-letter name for an angle? Yeah. This is why, guys. Watch. Can I call this angle C? Yes. Can I call it angle C now? No. Why? Because there's more than one angle at the vertex. So the reason you're allowed to call this angle C is that there's only one angle at the vertex. If there's multiple, then you can't. Then you had to use a three-letter name. Okay. I almost did that. Okay. So here we go. Let's say that's this angle I'm working with. My legs are labeled based upon this angle. The leg across from it, this one is the opposite leg. The leg next to it is the adjacent leg. And then, of course, this is always going to be the hypotenuse. So it doesn't matter what angle you're working with. So the legs, opposite and adjacent, they change based upon the acute angle you're using. Okay? If I was using angle A, this would become opposite, and this would become adjacent. All right, so here we go. When you're doing this, the sign, you're taking the sign, or SIN, the abbreviation is, of the angle. And it's equal to the opposite over the, what? Hypotenuse. That's what this stands for, opposite over hypotenuse. So for me, I could call it AB over AC. That's a length, right? AB, AC, that's a length between those 2 points. This one, of course, is the cosine, okay? It's the cosine. And it's abbreviated COS of C. But now we've got an A and an H. So it's the adjacent over the hypotenuse. So for this one, it would be BC over AC. All right. And then the last one down here, TOA, T stands for tangent. And that is TAN, abbreviation of C. And this is opposite leg over adjacent leg. So for me, that would be AB over BC. That should look familiar to you. Okay? That should look familiar. All right. Now, what were the ways you used right triangle trigonometry? There's 2 ways you guys have used it. To find either a missing side or to find a missing angle. Okay? One of the two. You have to be given, in order to do this, you have to be given information, right? If all of these right here are equations. This is an equation. This is an equation. That is an equation. In order to solve this, I would have to know two of the three things. I'd have to either know the angle in AB, or I have to know the angle in AC, or maybe I know both of the sides. But you have to know three things on the triangle in order to solve it. All right? And knowing that this is 90 does not help you at all. That's not one of them. That's guaranteed. Okay? So we're going to start by finding missing side lengths. Okay? So here's my next question. If I gave you the following, let's say I told you, let's see here. Okay? If I told you this, who can explain to me what that's saying? What does that mean? Brady? Okay, so if I were to draw a right triangle with a 30-degree angle in it, okay, so let's just do this right here. That's 30. That's a 90. Okay? This is saying that opposite over hypotenuse is 1/2. Now let's just think about this. We just did this. I just talked about special right triangles. We know if this is the 30, 60, 90, what is this? What do we label these as? X and 2x. So if I put opposite over hypotenuse, that is x over 2x, which is 1 over 2. Does that value change? Does that value of 1/2 change if I do this to my triangle? No. No, it doesn't change at all, does it? That's true no matter how long the sides are. It doesn't matter. The ratio would always be 1/2. That's the ratio. All right? Okay, great. So let's go ahead and, what do we got here? 21. We're about ready to end. Let's just go ahead and see what you guys can do with this. So I'm going to give you a right triangle here. Here we go. I'm going to tell you that this is 18 degrees, and I'm going to tell you that this over here is 3. Here's what I want you to do. I would like for you to find the missing sides. I'm going to just call this over. I'm just going to call this C, and I'm going to call this A. And I'd like you to find them to the nearest hundredth. So you're going to solve for C and A to the nearest hundredth. See if you're able to do that, if you remember how to do that. And then we'll do those as examples. Sign in these two spots. You're going to let them drain all your blood out of you, give you an oil change. What is this? 20. Yep. I was able to. Yep, so that's 1, 2, 3, 4 doors down on the right.
Thank you.
Yep. What is going on?
How's it going?
Hey man, I wish I was outside right now. It's nice.
I know it's like 70 degrees.
And then next week, guess what?
It's supposed to rain all next week.
I don't like that. You don't even ready to stay here.
I'm supposed to go to Top Golf, so that's
Yeah, maybe.
sounds
Like, you like, there are some days where it's not supposed to rain all day. It's like either morning or evening. It's one of those you can probably go out there. The nice thing is it doesn't be super warm over there.
I'm not right.
Hey, thank you too. Well, I didn't even recognize you. What in the world? What are you doing to yourself, bro? Changing it up, huh? That's right. Gotcha. Oh, okay. See, have a break. Thank you.
It ain't that bad. Last time I was there, we
I know you're not. All right, well, have fun. We're getting close. Yeah. Yeah, I know. La 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 la. Boom boom. Doo-doo. What? Sorry, Sam. Caught me off guard there, bud. Yep. So first thing you have to do is find out this first person's name. Okay? Write it down. The second person is going to get 9.3% of what this guy has got. The third person is going to get 9.3% of what the second guy got. Okay? So the only one that gets 4.12.5% is the very first person. Everyone else is going to get 9.3% of the previous person's amount. No, just that's what he's going to get. That's the amount he's going to get from Bill Fences.
So the next person gets 9.3% of his.
Not of Bill Fences, of the previous person that shook Bill Fences' hand. Okay? All right, let's go ahead. So let's say I want to find letter A. What ratio? First of all, what are we going to call this one over here? This is opposite. All right, great. So if I want to find this, this is opposite. This, of course, is adjacent. So opposite adjacent is what trig ratio? tangent. So I would write down, my equation would be tangent of 18 degrees is equal to 3 over A. You have to solve that. Now remember, this is a proportion. It's a ratio, but it's also a proportion. This is just over 1. So when you're solving this, it's what? You multiply and divide to get A. It's the fish method. How many of you guys were taught the fish method for solving proportions? See the little fish there? Isn't he cute? He's a little fish, okay? So literally, you take the two numbers that are diagonal, multiply these, and then you divide by the other one. So I know that for this problem, A is 3 divided by the tangent of 18 degrees. That's what it's going to end up being. Boom, boom, divided by that. Okay? Now, so you could type this into your calculator just like this, so there's no rounding up front. So let's go to, now, if you're using a graphing calculator, okay, or a regular calculator, you would just simply go ahead and go 3 divided by tangent of 18, boom, you'll get an answer. If you're doing it on Desmoso, where's my, there we go. You have a choice, okay? So you could use the graphing one. You could also use just a scientific calculator if you wanted to. You don't have to use the graphing one. You could use this because it's got sine, cosine, tangent right down here at the bottom. That is up to you, okay? So again, we know on this particular problem that we're just going to type in 3 divided by tangent of 18. Boom, 3 divided by the tangent of 18. And I get an answer, 9.23, is that what that says? Yes. Okay. If you do this on a graphing one instead, let's say you just always open up a graphing one instead. I could do the same thing, guys. 3 divided by, type it, tangent of 18. Boom. Now, notice what it did here. What did it do? Yeah. It's not in degrees. My answer is not in degrees. If I go over here and click this, okay, I'm not seeing it on this.
At the bottom.
Oh, here it is. It's in radians, which is another way of measuring angles. You have to make it in degrees instead. So if you do it on here, make sure that you're in degrees or you'll get every one of these problems wrong. Okay, you'll get every problem wrong. Okay, so 9.23 is the answer for the first one. So A is 9.23. Now, if I was telling my geometry students, okay, now you want to find C, I always would have students say, can I just use Pythagorean theorem now? My answer to them is this, that I don't want them to do that. Why? 2 reasons. One, if you got this wrong, you're guaranteed to get that wrong. Second, I just rounded this, which means what? If I use Pythagorean theorem, this is going to be further away from the actual answer. So I would want you to use the trig ratio again to find C. All right, let's do C now. Boom, we're going to do this guy. So now we're going to use opposite and hypotenuse, and that would be the sine ratio. So I would write that the sine of 18 degrees is equal to 3 over C. Again, this is going to be solved the same way. C is going to be equal to 3 divided by the sine of 18. So this one gave us 9.23, we said. Who can tell me what this is going to give me to the nearest hundredth? Kevin, you got it? 9.71. When I get done, immediately I say, do these even make sense? I know the hypotenuse better be the biggest, and it is. I know that this 3 better be the smallest because it's smallest the opposite, Angle. These have to be across from each other. So I say those look good just from an appearance point. All right? Boom. Does that all look familiar? Do you need me to do any more examples of that type? Are we okay on finding the missing sides? If you're done with that test, you can just put it on my desk. Okay. So the flip side then is finding missing angles. So let's go ahead and look at finding missing angles now instead. All right, so I'm just going to draw a right triangle here. Boom, boom. And let's say I tell you that this is 9 and this is 15, and I want to find this angle over here. Now I could call this letter X, or whatever. Let's just say I want to call this X. I will tell you right now, get used to this. Okay, so usually for us in here, if I'm going to give an angle, a variable, I'm going to give it a Greek letter variable. I will not usually use X's and Y's, all right? The most common ones that I use are that, which is theta. I also might use this, which is phi. Those are the two most common ones. I also might use that, which is alpha. And the other one I might use is this. It's a B with a tail. That's beta. Those are the four most common I will use. They're nothing more than Greek letters. So they're just variables. Variables are letters that stand for numbers. But in higher level math, when we start dealing with angle measurements, we will be using Greek letters instead. Okay? Those are the most common ones I'll use. So I'm just going to call this angle here theta. I want to find out what the measurement of theta is. Okay? All right, here we go. So the first thing I have to say is, where are my two known sides? Yeah. Well, probably because way back when, Greeks are the ones that kind of did all this. That's probably what they did. It's probably like just a way we've kind of stuck with it. Okay? I think also we kind of try to keep polynomials as like, what do we call our alphabet system? A's and B's and X's and that kind of stuff. We leave those more for like polynomials on the graph, rotational things and stuff. We try to use Greek letters because they're two different things we're working with. That's probably why we do it as well. I can't give you a for sure answer why we do that. We just do. All right, but here we go. So if this is the angle I'm working with, I label the sides respective. So this is opposite, and this, of course, is hypotenuse. So the ratio I would use is what? Sine, right? It's a sine. Okay, so if I wrote this down as an equation, it would say the sine of theta is equal to 9 over 15. Okay? Now, when I want to find the angle, okay, you will see me write this two different ways. One would be this. Theta is equal to this. So let's think about it. I used sine when I was finding a missing sign or a missing side. This is, what does this mean? It's the inverse. So sine finds the missing side, inverse sine finds the missing angle. They go opposite directions because that's what inverses do, right? They go opposite directions. This is one way of writing it. The other way you could write this is this. Okay, I got to figure out how to get rid of that stupid thing on this. I don't know what that's about. It says arc sine. Okay? Arc sine. Now, the reason that I can tell you why that's there, because this is related to circles. And if you remember anything, remember this. A central angle and its intercepted arc have the exact same measure in degrees. So when you're finding the measure of an angle, you're also finding the measure of an intercepted arc. That's the other reason, okay? Both of these. So you might see me write it like this. You might see me write it like this. They're both okay. So now we have to go to our calculators again. Okay, so if you're using a regular calculator, you're going to see behind sine on the faceplate, it's going to say most likely sine to the -1, inverse sine, which means you have to probably hit either shift or second or something to make that work. If I go to, here, right here. So I'm going to get rid of this. We're going to do it both ways, okay? So here, if I want to do it on here, let's clear all this off. How am I going to do it here? Well, I could do sine, but it's not going to give me what I want. So where am I going to find the inverse sine at, I wonder? Any idea? Anybody know? What's that? Go to functions. There they are. Boom, boom, boom. Okay? Sine. So what did I say? What was going in here? I don't remember what was on. 9/15. 9 divided by 15. And I get this answer. There it is. Is there another way I can enter it? Watch. Let's see if I can just type in this. Here we go. Arc sine of 9 divided by 15. Oh, that's actually quicker than going over, hitting function, and having to hit that button. I don't have to even do that. I can just stay on the main screen if I want to do that. Okay? So there's a couple ways you can do it if you're using a regular Desmos scientific calculator. If you're doing it on a graphing calculator, again, you have to be in degree mode. I can do it like this. I could go down to the keyboard, and I could go to functions, and boom, you'll see that there's sine, cosine, tangent, and here's all of the inverse sine, inverse cosine, inverse tangent somewhere over there. I just can't see it because it's right here, okay? But you know what? It is almost easier here to type this. Sine raised to the -1. Desmos knows you're doing the inverse. And then in parentheses, I'm going to put 9 divided by 15. Oh, it's up in the top. I don't want it up there, do I? 9 divided by 15. 9. Why isn't my dividing button? There it worked. Boom, there it is. You also could just type in arc sine of 9 divided by 15. Oh man, come on, you silly thing. Parentheses 9 divided by 15. There we go. So where you choose to do this at is up to you. Okay? Where you choose to do it at would be completely up to you. Right? So there would be 36.87 if I'm rounding to the nearest tenths. 36.87. All right. And then if I wanted the other missing angle, what's true about these two angles? They add up to 90. They're complementary. Okay? They're complementary. So you can just say, oh, 180 minus 36.87, boom, I get this angle then. Okay? Does this look familiar? The new thing here is probably this, the Greek letters, and that's not what you should get hung up on. They're just letters. And you'll just get better with that again. That's practice. So, any questions on this part? Do you guys feel pretty good about this right now? Okay, so let's make sure it's there. So everybody needs to go, and I'll put it up here as well. Let's see if it's showed up or not. So I'm going to go back. Desmos graph. And this. Classes. And let's just click on this one. And let's see if it posted. It did not. Ah! Let me come over here and check to see what's going on. Why that? Right. Add an assignment. This one here. I bet those are going to be old. Let me redo these. And student classes. Add a new period. 3rd-5th HPC. And 7th through 9th. HPC. Why didn't that just type? 7th through 9th HPC. Why is this not manage students and classes? Why is this? Where are the students at? All right. Let's just make a map. Can't print that everything off. Where are all my students at? They're missing. Manage students and classes. That's great. Where are my students? It says 0 students in there. Switch students for assignments. Create. Again. I cannot find you guys. They're gone. The students are no longer in Delta Math. Okay, let's do this again. What's my? You guys are gonna need your Chromebooks out. You get out your Chromie books. And I'm gonna have to give you my information. Okay. So you're going to go to Delta Math, DELTA MATH. Maybe I'll type it up here. Here, Prince. I'm going to go to Delta Math. Okay. And you're going to need my teacher code, which is this. Okay. So here's what I want you to do. So you're going to go to deltamath.com. You're going to create an account. Oh, yeah. Maybe I didn't have you guys do this. Maybe I did my other class. So you should find it where it says create account. You guys see that on there? You're going to type in my teacher code 247744. You guys can make your own username. You can make it your school email if you want. You're going to do a password. Okay, and then you're going to, when you get there, you're going to select the section from a drop-down menu. You can if you want. You can use any email you want. It really doesn't matter. Okay. When you guys get, did you guys get to section yet? What do you see? Well, did you see a 3 through 5th or something, or what did you see? Okay, yeah. So you're gonna just choose the 3 through 5th is what you're gonna HPC for honors pre-calc. You see it? That's fine. Okay, yeah, because I have to repost it now because it's not there. So once everybody has created that, I'll have to I had an assignment. I'll have to just redo it, which is fine. I can do that. And an assignment. This guy here. We're going to put it in this class, and this class. Boop, boop. And we're just going to due date be done tomorrow. Doesn't matter. Actually, I'm just going to make it. And, it's going to be short and sweet. Okay, so do you see anything if you refresh it now?
Yeah.
You see it now? Good. Okay, each one's just got 5 questions. It's pretty straightforward. It's identifying. I think one of them's finding sides and one's finding angles.
Bless you. Thank you. Yeah, it's all you. It's a soul state. Chillax. Keyboard. Wow. There you go. You guys are close to spring break. You're getting close. How was it today? What? This. I didn't respond because I didn't. Got like back here. This is where you were when we left off. And then I really started with it. Like, That's fine. You're okay now with it? Yeah. Perfect. Perfect, perfect, perfect. Guys, have a great spring break. Stay safe, have fun, be safe. Thank you, sir. Whoa, this is Arizona? Oh, sweet. Nice. Okay. Well, you have to pick time. We finished that for a moment. Yeah, just whenever. Yeah, whenever. Yeah, I think it's gonna close like by Saturday, but tomorrow we have like 10 minutes to do it. Okay. Thanks. It's just like, it's just practice to make sure we're all ready to go when we come back from spring break. Yep.